Okay, yes. So I hope you can see me and hear me. Okay, so very good. Welcome to today's class. Good evening, all. Happy evening. So I hope you had a good weekend. Okay, so a fresh week. Okay, so new week. So let's refresh our memories first. Okay, about the chapter called the gravitation. Okay, which is simple enough. Do not complicate stuff. Okay, so first, let me just quickly respond to your messages. Okay, and then we're going to have a quick restart about the chapter gravitation. Okay, so now, so on your screen, okay, so first I will share the notes, okay, which we were discussing, okay, and then we'll refresh our concepts about gravitation. Okay, so Shraddha, Diya, Pranamya, Samruddhi, Rashmi, Sneha, Suhani, Shravana, Janvi ma'am, Priyanka, Yash, Meeta, Tanisha, Siddharth, Nitisha, then Amog, Gautami, everyone. Okay, so everyone, Amaya, and including Arpita. Okay, so everyone, good evening all. Okay, good evening. So yes, very nice. So Yesh is telling about yesterday's match. Okay, so when Tiwatia completely changed the game. Okay, just before the moment he started eating sixes, everybody was scolding him. Okay, including the commentators. Okay, questioning the team management's decision of sending him two down. Okay, so but then in just one over, he showed what he is capable of. Okay, so very nice. So anything can happen. Anything can happen. You can also change the game like Tivatia. Okay, you can change your attitude first. Okay, so do not think that physics is difficult or gravitation is difficult. Okay, so just have an open mind. Be like Tivatia. You can also understand everything. You can also become a star. Okay, you can also become a star. Okay, so very nice. So let us first see our concepts again. Okay, so humble request, do not overcomplicate things. It is very simple. Only 3 points I want you to understand. Okay, first, just listen to what I am telling first. Okay, so just take the knowledge first. After me completely, explaining, so then you can start questioning. Okay, but first do not unnecessarily blame or question things. First understand the knowledge. Okay, understand the concept, and then you can think about other perspective. Okay, so first, so let us quickly see what we learned in the previous class about the gravitation. Okay, so let me tell you, you can see here, the focus is not on centripetal force. Please understand, you will learn in detail about the centripetal force, about the centripetal acceleration, okay, and about the angular velocity, everything in detail in 11th standard, third chapter. Please understand. You will learn in depth about this formula, okay, how did this formula come, derivation, everything. So there you can go in depth. Now for 9th standard, only 3 points you need to understand. Okay, only 3 points. What are those 3 points? I'm gonna write it now. Okay, so I'm gonna write those 3 points now. Okay, about the complete revision only of centripetal force. Okay, so do not overthink, do not put burden. Okay, so it is not at all worth it. 3 points you understand, remember, that's all. More about this 11th standard, along with the derivation, along with the formula, you will solve. Okay, so now 3 things you understand about centripetal force. What are those 3 things? If an object is moving in circular motion, okay, circular motion, if the object is undergoing circular motion, it is all because of centripetal force. Okay, it is due to centripetal force, where the force is towards the center. Okay, where the force is towards the center. Second point I am writing. Okay, centripetal force is nothing but center seeking force. This force is at the center. Okay, at the center. It is coming towards the center. Okay, this force direction is towards the center. Okay, and how is it towards the center? It is perpendicular. Okay, it is perpendicular, okay, to the motion of the object at a particular point, or you can also tell perpendicular to the velocity. Okay, so in the diagram wise, if you look at this diagram, always centripetal force is towards the center. Okay, centripetal force is always towards the center. Okay, and next, so this and all, white color is my velocity. White color is my velocity. Okay, F. All that F is centripetal force. Okay, towards the center. Last point. Okay, last point which you need to understand. If the centripetal force is removed, okay, if the centripetal force is absent, then the object will move in tangential position. That's all. Okay, if the centripetal force is removed, then the object will get thrown off, in tangential direction. In tangential direction. That means it touches the circle at only one point. Okay, so it touches the circle only at one point. Okay, so that is our tangent. Okay, so that is our, you can take this as a line segment. Okay, so that is our tangent XY, touching the circle at point A. This much only, man. Okay, this much only. Our idea is to learn gravitation. Please understand. The way we are linking is that we are just calling the gravitational force acts as the centripetal force. That is the connection. That's all. Okay, so do not unnecessarily, okay, overthink and unnecessarily, okay, hurt yourself. Okay, only these 3 points is what you need to know about centripetal force. Ashte. Okay, don't do overaction. Okay, only these 3 things. Whenever you see a circular motion is because of centripetal force. Where is the centripetal force? At the center. As the name indicates, at the center. It is towards the center. It is perpendicular to the center. Okay. And last point, if you remove the centripetal force, the object gets thrown off in the tangential direction. Only these 3 things. That's all. Okay. If you understood these 3 things, okay, click on the yes icon. Okay. There's a long way to go. Few more other things you will understand while we are doing the chapter. Okay. You cannot learn everything in the first class. Okay. Throughout the chapter, you will learn few things, and together at the end of the chapter, you will have concrete idea about what is happening. Okay. So you have to wait. Till then. Okay. These 3 things, if you understood, then you can click on the yes icon. In order to understand better, I have one animation. Okay, watch this animation carefully. You'll understand even better about the centripetal force.
Imagine you've got a tennis ball.
So they explain few things. Okay, so with the help of like very good animation. Okay, so as you can see here, I want you to notice this diagram. Okay, very nice. So as you can see, so these are the 3 things that you should know about the centripetal force. Okay, so the idea is to connect the centripetal force to the gravitation force. It is the link. Okay, to connect centripetal force to the gravitational force. That's all. Okay, the next point. So what I'm going to write here, the next point, what I'm going to write here is the connection. Okay, is the connection. So once I complete this, okay, so once I complete this, so what will happen is that afterwards, I will tell you about centripetal versus centrifugal. Now, because if I tell about centrifugal now, you will forget both. Okay, so hence I am saving that centrifugal at the end of today's class. Okay, so Sujan is asking if centripetal force is removed. So then what happens to the acceleration? If the centripetal force is removed, just now I said it is going to move in the tangential velocity direction. That's all. Okay, so whatever direction it was there, it's going to move in that particular direction. Simple. Okay, so as long as it is in the circular motion, it is going to have an acceleration called centripetal acceleration. Formula also I have written. You open your eyes and see. Okay, AC is equal to V square by R, which is nothing but omega square into R. Okay, what is R? Okay, so R is your radius vector. R is your radius vector. What is this? 11th standard, 3rd chapter, you will understand. Okay, 11th standard, 3rd chapter. Do not unnecessarily think about other things. 3 points you remember, Sak. Okay, these are the 3 points that you remember. Okay, if you deviate from this, then it's very difficult for you to bring back to the concept. Okay, these 3 things you remember. So how we are going to connect this topic to gravitation is now what I'm telling. Okay, so in the solar system, okay, in the solar system, so the motion of the planets, the motion of the planets around sun is due to the centripetal force, is due to the centripetal force. Okay, so here the gravitational force is acting as the centripetal force. Okay, I'm going to tell here the point, the gravitational force of the sun with those planets, okay, is acting as the centripetal force, due to which the planets are revolving around the sun. Okay, so that is the reason why our solar system, okay, is stable enough. Okay, so the planets do not fly away. Okay, the planets are revolving around the sun. They keep on revolving as long as you have the gravitational force of the sun. Okay, that's all. So now everything what I write, you should also write. Okay, so whatever I'm writing in the notes, okay, so there is no question at all. Okay, you must write everything. Okay, so over here, the centripetal force is nothing but the gravitational force. Okay, of what? Gravitational force of the sun. So what is the gravitational force? That is only the chapter which I'm going to tell in the next topic. Okay, so that is what we are about to learn. Centripetal force over. That's all. One word answer. Centripetal force is the center seeking force. That's all you need to remember. Unnecessary overaction don't do. Okay, so we have to focus on the gravitational force. That is our topic. That is our chapter. Okay, so the sun's gravitational force is the centripetal force, because of which, okay, because of which our planets are moving around. Our planets are revolving around the sun. Okay, so now, so please understand, I told our gravitational force acts as a centripetal force. I did not tell gravitational force is always centripetal force. I did not tell that. I told gravitational force is acting as a centripetal force in the solar system. The gravitational force of the sun acts. I hope you know what is the meaning of the word act. Okay, acts as a centripetal force in this case, because of which our planets are able to revolve around the sun. Okay, the planets are able to revolve around the sun. Okay, so what is this gravitational force? If you allow 10 minutes, you will understand. Have patience. Okay, madam was once upon a time telling that the new generation students do not have patience. Now I completely agree with madam. Okay, so you people should have little bit of samadhan, patience. Okay, all your questions will be answered if you allow me to go to the next topic. I told now, if you allow me to complete the topic, then you'll understand. In between, if you keep blocking or interfering like this, okay, so then it will be difficult for you to understand. Okay, so I want to go with the flow. Okay, let me have the flow first. Once I tell topic done, okay, you ask questions. Okay, that time you ask. Okay, so till then you please wait. Talme, have little patience. Please wait. Okay, so the next thing here is, what is this gravitational force? Okay, so what is happening in this case? What is the gravitational force? Okay, so that is what I'm gonna write now. Okay, the credit should go to Isaac Newton. Okay, so who gave this theory of, you gave this law of gravitation, okay, so called as universal law. So I'm going to write here universal law of gravitation. Okay, so now we're going to see about the gravitational force. Okay, so first I'm going to write the law. Okay, so in the exam they will ask this for 2 marks, the law and the formula both. Okay, so what is this law? So this is what Newton gave the law, the most famous law, the most important law in physics. Okay, that is universal law of gravitation. Every object in the universe, every object in the universe attracts every other object, attracts every other object with a force, attracts every other object with a force which is directly proportional, which is directly proportional to the product of the masses, to the product, to the product of the masses, and inversely proportional, and inversely proportional, inversely proportional to the distance between them. Okay, to the distance between them. Okay, so basically the center. Okay, so that is the distance between the centers of the object. Okay, so this is what is our universal law of gravitation. Okay, so given by Newton. Let us break this into parts and try to understand. Okay, so the first line, so if you carefully see, every object in the universe attracts every other object. Okay, that means whatever you see in the universe, everything is attracting every other object. Okay, so wait, I'll come to the point of why the objects are not moving close to each other. Everything I'll tell. Okay, have 10 minutes patience. Okay, so every object in the universe attracts every other object, but this force, okay, so this force, the gravitational force, is directly proportional to the product of the masses. Okay, so let the masses be m1 and m2. You have to carefully see that we take only 2 objects at a time. We cannot take 10 objects at a time. Illa, only 2 objects. Okay, it exists between 2 objects. Okay, so you have to take two objects as a system. As a system, you have to take only two objects. Okay, so object 1 having mass m1, object 2 having mass m2. Okay, if the object is not having mass, then you cannot put this gravitational law at all. It is only for matter. It is only for substances having mass. Okay, only for matter, substances having mass. Okay, and this force is also inversely proportional to the distance between them. Okay, I will write here, so one small addition, to the square of the distance. Okay, so I just will edit this, is inversely proportional to the square of the distance. Square of the distance between them. That means their centers. Okay, so you have to combine this. You have to combine these two. So if you combine these two, okay, so what will I get? I will get like this. Okay, but still I have to use the equal to sign. The proportionality sign, if I have to remove this, then I need to involve one constant. Okay, I got to involve one constant, and that constant is nothing but your capital G. Okay, so that constant is nothing but your capital G. Okay, so hence this is your, okay, so this is your formula of universal law of gravitation. Okay, so where I'm going to write each and every term. F is the gravitational force. F is the gravitational force. Okay, capital G is the constant. Okay, so is the universal constant. Okay, is a constant. Okay, so this is a universal constant. Okay, its value is fixed. So I'm going to tell the value of G as well. So I'll write here G is equal to 6.673 into 10 raised power minus 11. Okay, so Newton meter square kg minus 2 is the unit. How did we get that? That also I will tell. 10 minutes patience you have. Okay, so next I'm going to write M1 is mass of object 1. M2 is mass of object 2. Okay, so what is this D? D is distance between their centers. Okay, distance between their centers. So suppose if I have these two circle like this, if you have other design also, no, if you have other objects, suppose the object is square, the center of mass of the square, okay, is what we consider. That's all. Okay, so whatever object you take, the object center, okay, the object center is what we need to focus on. Okay, so this is what we call it as D. Okay, the distance between their centers. So this is having mass M1, this is having mass M2. Okay, so if you use this formula, then you will be able to calculate the gravitational force. Okay, so now only this much, if you understood, then you can click on the yes icon. Okay, simple. Universal law of gravitation, okay, is a very simple law which says that, okay, so which says that every object in the universe attracts every other object, so which is directly proportional to the product of the masses and inversely proportional to the square of distance between them. Okay, for writing this statement, 1 mark. 1 mark for writing the complete sentence statement. I'll write here 1 mark. And for showing this formula, 1 mark. Okay, so total 2 mark question. Okay, so total 2 mark question. So now, as I said, I haven't completed the topic yet. So you have to wait till I complete the topic. So once I complete the topic, so then I will ask, then I will give you permission to ask questions. Okay, so till then, have samadhan. Okay, have patience. 6:35 today, I'll do one thing. I will give all of you the unmute option. Whatever you want to ask, which you did not understand, ask. Okay, till 6:30, please sit quietly and listen to everything that I'm telling. Okay, till then, please do not interrupt the flow. Okay, so till 6:30, have patience. I will complete the topic of gravitation. Full I'll explain. After that also, if you have doubt, 6:30 sharp, okay, you please remind me. I'll give you a chance. Open mic, you can talk, okay, and ask the question. I hope that is the deal, which is clear. Okay, so now till this much only, step by step installment. Okay, I did not complete the topic. Have patience, please wait. Okay, so answer to the question that I'm asking. If you understood this statement, click on yes. Okay, if you understood that statement, click on yes. One by one, step by step, we will go. Okay, next, if you understood this formula, how did we write this formula? Okay, you can now click on the yes icon if you understood this, writing the formula. Okay, and now, so some of you have clicked on no. So let us see. Okay, so those who have clicked on no, that is Amol. Okay, so next, who else have clicked on no? So whoever has clicked on no, so you can please tell me in the chat what you did not understand after 6:30. Okay, so not now, after 6:30. Okay, so if you have anything, you can definitely tell after 6:30. Okay, so next, I have explained the terms also, everything one by one. Okay, so in order to help you further understand, so I will play this video about the universal law of gravitation. Okay, so whatever I just now did, the same thing. So you can see the animation as well. Okay, so that you can understand again. Okay, so what exactly is this universal law of gravitation? Okay, so on your screen now, I will play the video. Okay, so I'm going to share the screen now. So watch this video carefully. Okay, so you will understand lot of things if you focus and concentrate and understand this video. Other information also we have to gather, okay, from this video. Okay, so as you saw, it's like very simple. As I told, after 6:30, I'll give you a chance to speak. So till then, please control yourself and carefully listen to everything. You have doubt, you write it down in the book. Okay, write it down in the book what you want to ask. So 6:30 sharp, I'll stop. Okay, and I'll ask you to shoot the questions. Okay, you can directly shoot the questions. Till then, please control yourself and listen to the teaching part. Okay, so as you see here, so the force, okay, what we are talking about is the gravitational force. Okay, so it is directly dependent on the product of the masses. Both the masses you need to consider. Okay, and over here, so whichever object is having more mass, that object is dominant. Okay, dominant, superior. Whichever is having more mass, that object is superior. Okay, so we always take two objects at a time. So over here, M1 and M2. So who can tell me which object is superior, dominant? Which object is dominant? Very nice. Okay, as all of you have told, okay, M2 is dominant, is superior in my example. Okay, in my example. So then, of course, object M1 gets pulled towards M2. Okay, object M1 gets attracted or pulled towards M2 because M2 is controlling, M2 is dominant. Okay, M2 is superior. Okay, hence M1, the chotu mass, will get attracted towards the bada mass. Okay, so over here, so they have taken this gravitational constant G. Okay, so as you saw in the video, so it is a universal gravitational constant having the value 6.673 into 10 raised to power minus 11. How did you get this value? So in 11th standard, you will do the derivation part about how you got this value. Okay, so using a sensitive balance or the torsion balance, our Cavendish. Okay, so this is the name of the scientist. Okay, so Henry Cavendish. So used the sensitive balance or The another name is torsion balance. To determine the value, okay, to determine the value of capital G. Okay, so to determine the value of capital G, and he was successful in finding out the value. So that is 6.673 into 10 raised to power minus 11. So what is this torsion balance? So I'm just going to show you here, but we will never do derivation. It is out of the 9th standard level. Okay, so I'm just going to show you. So not Henry Cavill, Henry Cavendish. Torsion balance. Okay, so this is the experiment about Henry Cavendish torsion balance. Okay, so over here. So not so complicated experiment, simple enough. Okay, but you do not have the concept set. Okay, to able to derive this. Okay, so this you will again learn. See, everything you will learn in 11th standard. 9th standard is just chuma, what you call an introductory course. That's all. Okay, they'll tell all the rules. They will not let you play. Okay, they'll tell all the rules. You will only play in 11th standard. Okay, so now they'll all tell you all the rules. This is just like telling the rules of the game, of the cricket, but they'll not let you touch the bat and ball. No, no, no. You cannot play. You should only sit and listen the rules. 11th standard, you will play. 11th standard, they let you play with all the concepts, knowledge, everything. Okay, so now you just have to know the rules. Okay, so you just have to know the concepts. Okay, so over here about the units. Okay, since EF is equal to G. Okay, see the constant. So every time do not think the constant will be K only. K is just an alphabet. Okay, so K is not there. Okay, there is a short power issue. Okay, so if you can hear me, you can. Cannot hear me also, you send in the chat. Video will be connected. Okay, the video will be connected back. Okay, so I hope you can listen to my audio. You can hear my audio. Okay, if you can hear me, so then you can type in the chat and send it to me. Okay, so once the power is back, okay, so once the generator is back, I'm just going to reconnect. Okay, so use the generator. Okay, so anyways, so do not worry. I will just show my screen. Okay, so over here, so as I was telling you, every time you need not have K. Okay, so K is just an alphabet. Okay, to show the constant. Okay, so over here, K is not there. Instead of K only, we are using G. Okay, so G M1, M2 divided by D square. Okay, this is the formula. Okay, so here K is not there. The constant itself is the capital G. Why G? Because that is given for gravitation. Okay, it is given for gravitation. Okay, so over here, okay, so regarding the units, okay, so regarding the units of G, Okay, so just rearrange the equation. Okay, such that we can tell the units of G. Okay, so if I bring the D square on the top, so I will get like this. Okay, so now what I'll do, so I will bring M1 and M2 to the denominator. Okay, so now you just have to look at the units. Okay, this force is having unit of Newton. Okay, this distance has units of meter. Okay, distance into distance is nothing but meter into meter. That is meter square. Okay, so in the denominator you have kg square. Okay, this is your capital G. Okay, so what units? So if you carefully write this, so this will become your units. Okay, so units of capital G. Okay, so I will again show you Henry Cavendish. So according to his formula, okay, so he made one experiment, okay, and he found out the value of capital G. Okay, so this capital G, okay, so this capital G is our universal constant. Okay, so this capital G is our universal constant. Okay, I think my audio will be better now. Okay, so I just changed the Wi-Fi connection. Okay, so you can hear me now properly. Okay, so as I was repeating, so Henry Cavendish, okay, so made one experiment, okay, and then he found out the value of capital G. Okay, so which turned out to be 6.67 into 10 raised to power minus 11. But what about the units? So the units you can calculate like this. Okay, units you can determine, you can find. Okay, I think now you can hear me. Okay, so here what is happening? So they have taken the same formula, they just rearranged. Okay, formula such the capital G. Okay, just a second. Okay, I'm just reconnecting it. Okay, so just a second. Okay, so once it gets connected, okay, so I will show you the screen again. Okay, so you can hear me now properly. And as I was telling you, So I'll just show the screen again. Okay. And then those who have doubts, okay, so I'll give you chance. Okay. So what we did for the units of G, so we just rearranged. Okay. We rearranged the formula such that we kept G on one side. Okay. And all the other quantities on the other side. And all the quantities that we have, we took their units. Okay. And that is how you get the units of G. So if you understood how we got units of G, you can click on the yes icon. Okay, so together the total value of G, okay, is having value of 6.673 into 10 raised power minus 11. Okay, so Newton meter square kg minus 2. Okay, that is to the power minus 2. Okay, so as I told, so we'll stop here. Okay, and for all those amazing people, okay, so who have doubts, okay, so I'll give you a chance. You can raise your hand. Okay, so you can raise your hand. Okay, so I'll give you a chance for those to speak and then we can go for the quiz. Okay, so but before you ask the question, so I'm going to repeat again. So this is universal law of gravitation. Every object in the universe attracts every other object. Okay, so it depends on the masses as well as the distance separating them. But whoever is having more mass, that is superior, that is dominant. Okay, so compared to me and the earth, earth is having lot of mass. Okay, so hence earth is dominant, earth is superior. So hence I get attracted towards the earth. You, me, all of us get attracted towards the earth. Okay, we should only take two objects at a time. Okay, so that is the rule. Okay, so when you're talking about the pen, okay, the pen and the me. Okay, so now both of our masses is very less. You do not believe? Substitute the values in this formula and you will understand how much gravitation force is existing between me and the pen. It is less than 0. Very, very less than 0. Tomorrow in the numericals, I'm going to solve that. If you allow me, if you give me time, I would have solved it today only. Okay, but tomorrow in the numericals, I'm going to tell you that. Okay, that's why please have patience. Everything we're going to see. Okay, between this pen and the me, both of our mass is so less that the gravitation force will go less than 0. That is why you cannot see any attraction between the pen and the me. But you always see attraction between you, me, objects on the earth, because earth's mass is bloody 6 into 10 raised to power 24 kg. Okay, you see how big is that? Your mass, my mass is nothing in front of the earth's mass. Okay, so that we will discuss in tomorrow's class. Okay, but as I told, so those who have doubts, okay, can quickly raise your hand. Okay, so I'm going to give you a chance. So whatever you want to speak, this is the chance. Okay, so on your screen, yes.
Sir, why is it d square, sir?
Okay, that is the rule which he got to know from Kepler. There's inverse square rule of Kepler. In your textbook, if you see, there's a brown box in which it is given.
Yes, sir.
Okay, but Kepler's law we will not touch in 9th standard.
Then
okay,
if M1 is equal to M2, sir, you told
if,
M2 is superior, then if M1 and M2 are equal.
So then both of them will find an attractive force. Okay, so both of them would try to move towards each other.
Then if Earth and some star light years away from it, why both are not attracted?
Look at the distance.
It is inversely proportional, so sir.
So you see how far it is. Look at distance square. That is very, very low value.
Yes, sir.
Okay, so that is the reason.
Okay, sir. Thank
Okay.
you, sir.
Yes. So others. Okay, very nice. So yes, she clarified its doubt. Okay, anybody else? Okay, so we are asking doubt. Okay, so you can definitely, raise your hand. Okay, I'll give you a chance. Okay, so yes, Amaya. Okay, Amaya is asking, it is to calculate the gravitational force between two objects. Yes, at a time, only two objects. At a time, only two objects. Okay, you cannot have 4-5 objects at a time. Only two objects we'll take as a system and we will calculate it. Okay, and if anybody else has doubt, you can raise your hand. Or if you do not want to raise your hand, you can send me in the chat at least. Okay, so Manya has a doubt.
Hello, sir.
Yes.
So, as it is given there that the square's distance, sir, what does it mean that the distance between mass 1 and mass 2 square?
Yes. Okay.
Okay, sir.
You see a
Okay, sir.
distance between the center. You see here, I marked center. You look at the diagram. Okay, distance
Yes,
between
sir.
the centers. Okay, that is square.
Yes, sir. So if the distance is 10 centimeter between both of them, then it is 10 square, no, sir?
Yes, but you have to convert into meters, SI unit.
Yes, sir.
Okay.
Okay, sir. Thank you.
Yes, welcome. So very nice. So Manya clarified her doubt. Okay, so next, anybody else who has, you can send me in chat also. Okay, you can send me a doubt. So Kunal is asking, why doesn't Earth get attracted, okay, towards the sun? Okay, because you see, sun is having the mass, more mass compared to Earth, and sun is our, having that centripetal force. Okay, so the gravitational force of the sun itself is acting as a centripetal force. That is the reason why Earth is going round the sun. Okay, revolving around the sun. Okay, because of the gravitational force of the sun. Okay, if the gravitational force was not there, then Earth would have gone somewhere lost in the space. Okay, so that is the first point that I wrote in today's class. Okay, so Pranami is asking if both objects have same mass. Okay, so then it would collide. Okay, it won't collide. It will just little bit move towards each other. That's all. Because you see here, the values is such that you won't see much difference because the gravitational force is the weakest force in the nature. Okay, if you do not know, then I'll write this point. So please note, gravitational force is the weakest force in the nature. Gravitational force is the weakest force in nature. Okay, so you cannot see a major movement because of the gravitational force as such, because it is like very, very weak. So once we solve a question, then you will understand why is this very weak. Thanks to 10 raised to power minus 11. That is bloody small. Okay, so you look at the value is so small. Okay, so that is the reason. Once you try to calculate using the formula, okay, then you'll understand. Okay, so Karthik is asking if gravitational force is applicable to objects at a time. So there are multiple objects acting on each other, like the sun and the earth. While considering, you take two objects at a time. Okay, while calculating, if you want to know what is the force, just for example, IPL is going on. Do you think all 8 teams will come together and play? Never. Two teams will play at a time, and the winners will play the final. And in final, whoever wins, that team will win the IPL. Same logic. If there are 8, 9, 10 objects, two objects you will take. Okay, and you will figure out the gravitational force between them. You cannot take 10 objects and figure it out. Okay, you choose 2 objects between which you have to find the gravitational force, put it in this formula, solve. Okay, and you will get to know. Okay, so on others, okay, so Amma is asking, why doesn't Earth revolve around Jupiter since it is near to Earth than the Sun? Look at the mass of Jupiter and the mass of the Sun. Sun is huge. As I said, the dominant, superior, who is superior? Sun is superior. Then how can Earth leave Sun and go and revolve around the Jupiter? Never it's going to happen. Okay, Sun is the head of the family. Sun is having huge mass. Nobody can tackle it. Okay, if some other celestial object is there, okay, so that can change the system. So why is Earth rotating the Sun? Kunal, Earth is rotating around the Sun because of the gravitational force, which is acting like the centripetal force. Okay, Amog is asking, then what about the upward movement of water in the plant? Amog, that upward movement of water in the plant is because of the pressure difference. While we're talking about xylem, we did it long back. Okay, that is the pressure difference. That is different. Okay, so Sri Krishna is asking, if the gravitation force is the weakest, then how can black hole attract entire universe? You please get your facts correct. Okay, so black hole will not attract everybody. Black hole will only attract those objects which are near its vicinity, which is near its region. Okay, it doesn't attract everybody away some bloody 500 light years away. It won't attract. It will attract only those which comes around its vicinity, around its region. Okay, so please, before asking things, you please get your things correct. Okay, get your information correct. Okay, Kunal, as I told, the solar system and the Earth, if you allow me, tomorrow's class, when I continue the topic, you will understand. Have patience. Okay, so as I mentioned, the solar system exists because of the gravitational force of the Sun, which is acting as your centripetal force. Okay, so how, why, all those things? The entire chapter is about that. You are not allowing me to continue the topic at all. Okay, once I continue the topic, then you will get to know. So Amma is asking, what is the strongest force in the nature? That is a strong nuclear force. The strong nuclear force is the strongest force in the nature. Okay, so I think, see, the other things, okay, so I will just keep it aside. Okay, so now I just have little bit of time. Okay, so whatever time I have, okay, so I'm just going to do one last full revision. Okay, and then I'm going to run for the Kahoot quiz. Okay, see, again, I'm telling you, have patience. I did not complete the chapter yet. You are not allowing me to complete the topic only. Okay, if I complete the topic, okay, so then it will be appropriate for you to ask the doubts. Okay, so I'm still in the middle of the gravitation. Gravitation law only you did not allow me to explain. Okay, so if I complete the full gravitational universal law of gravitation, along with solving the numericals, then you will get clarity. Okay, so till then you please wait. Okay, so have patience and we're going to solve some questions based on this. Okay, and then you will have an idea. Okay, so all I am going to say is that, okay, so today, regarding the centripetal force, okay, here, centripetal force is the reason because of which circular motion happens. First point. Second point, centripetal force is acting towards the center. It is perpendicular to the velocity. Perpendicular means 90 degree. Okay, and this force, centripetal force, if you remove it, then the object gets thrown off in the tangential direction. So what is the tangential direction? I did the diagram. You please open your eyes and see. Okay, so if I remove the centripetal force at the point A, So then it gets thrown off in the direction XY. Okay. So for example, like this. Okay. If I cut the centripetal force, or if I remove the centripetal force, the video, I showed the video. If you did not understand, please watch the recorded video again today after the class. Okay, I think that should give you some idea. And coming to solar system, so the solar system exists. Okay, it's all because of the gravitational force of the sun, which acts as a centripetal force. Okay, look at the word, I said acts. Okay, which behaves as a centripetal force, because of which all the planets are revolving around the sun. Okay, and what exactly is this gravitational force? Okay, this is a beautiful law given by Isaac Newton. Okay, so which clearly tells the relationship between the force is directly proportional to the product of the masses and inversely proportional to the distance between them. Okay, square of the distance between them. Okay, and here you have the capital G as the constant, so which was calculated by Henry Cavendish, having the formula 6.673 into 10 raised to the power minus 11. How did we get the units? For that, we did here one chota derivation, okay, to get the units. If you did not understand, please after the class, watch the recorded video. So tomorrow, we're going to come back and see some other interesting information regarding the universal law of gravitation. And we will solve numericals. Then only you will understand, okay, why the objects are not getting attracted. Okay, why if a teacher, okay, if there's a teacher here, okay, if there's a teacher here and there's a boy here, okay, so why are they not getting attracted towards each other? Everything we'll see in tomorrow's class with the help of numerical, if you allow me to teach first. Okay, once I complete the topic, okay, so as I gave you chance today, so tomorrow also I'll give you chance. That time you ask doubts. Okay, but first listen to the topic. So on your screen now, let us see how much you understood in today's class. Okay, so on your screen now, I'm going to launch the quiz. Okay, so enter this game pin, okay, and join the quiz. Okay, so please take only 30 seconds to join. Okay, so here you go. This is the game pin. So enter this game pin and join the quiz. Okay, so last 10 seconds. Okay, so Sri Krishna is asking this doubt. Okay, will quantum particles also attract? Okay, so quantum particles, they do not follow any gravitational law. Okay, so for quantum particles, we have quantum mechanics. Okay, so for those who do not know about quantum particles, okay, so quantum particles are the ones, okay, so which is present. You can consider all these electrons, protons, neutrons, and all the other things, subatomic particles, okay, and everything else. Okay, for quantum mechanics, you have like different set of rules. Okay, so this is only for the macroscopic objects. Okay, the Newton's mechanics is for macroscopic objects, not the microscopic particles. Okay, so I think I answered all the questions which you posted in the chat. Okay, so if I did not answer any of them, you send it again in the chat. Okay, so I will answer till I start the game. So over here, you have to choose all the relevant points related to centripetal force. Okay, so there you go. Okay, all the points are related to centripetal force. Okay, the correct option is all of these. Okay, the centripetal force is the center seeking force. It is perpendicular to velocity, and the centripetal Okay, I think you can hear me. Okay, you cannot see the video part. Okay, but at least I think you can hear me. Okay, you can send in the chat if you can hear me properly. Okay, at least if you can see the screen. Okay, very good. So screen is more important. So next question. So look at the screen. You can see the question. So read the statement. So this is about the universal law of gravitation. Okay, so very nice. As per universal law of gravitation, every object in the universe attracts every other object. But the attraction is so weak, because the gravitation force itself is very weak force. Okay, only if the mass is big, then the gravitational force makes sense. Okay, big mass means I want mass as big as sun or the earth, so big. Okay, so like some lakhs and lakhs of kgs of mass. Okay, if it is that huge only, you can see proper attraction, otherwise no. Okay, tomorrow we'll solve some questions, you will understand. So last question, you have to fill in the blanks. Okay, so let us see how many of you got this correct. Okay, you just have to fill in the blanks, that's all. Okay, I've already written the value. You just have to mention the 6.673 into 10 raised power minus 11 that I have already put. Okay, so that's why I said fill in the blanks. Look at the question, fill in the blanks. So there you go. With this, let us see the podium. So third position we have Vishwas. So second position Diksha. And the winner of today's quiz is Yash. Okay, so congratulations all. Fourth position Swayam. Fifth position Pranamya. Okay, so all of you, congratulations. Okay, see you again tomorrow with much more wonderful explanations of gravitation as well as some very interesting examples. Okay, picture abhi baki hai. Aap samadhan mein raho. Tomorrow we'll see much more interesting things. Okay, so with that, I'm going in today's class. Okay, thank you so much. So see you again tomorrow. Bye bye.